Lead-acid batteries that have been declared discarded can be restored to near-new condition after being manually recycled by skilled Pakistani workers. But how do they manage to repair them without replacing any parts? The answer lies in Pakistan, at a repair workshop in Peshawar. This battery is currently unusable due to its diminished ability to store charge. In many countries, it would go straight to the scrapyard. But after being examined by a technician, he claimed it could be repaired without replacing any components. Before starting the repair, the technician first drains all the electrolyte solution from the battery to facilitate the following steps. Next is the disassembly process. He uses a hammer and chisel to remove the positive and negative terminals, then strikes the connecting area of the top cover to separate it from the battery body. He continues tapping around the top ridges of the cover to fully detach it from the battery's internal compartments. This process is relatively straightforward, but care must be taken not to damage the battery casing, otherwise, repairs cannot proceed. Once the top cover is removed, the interior reveals a dirty and degraded state. The electrode plates are covered in impurities, which explains why the battery could no longer hold a charge. The technician's next step is to disconnect the connectors between the individual plates to separate them. Once all the plates are removed, he uses a hacksaw to cut off the connecting terminals. Only after this step can he inspect the inner condition of the plates and separators. From the impurities falling off the plates, it's evident that the root cause is a lack of electrolyte solution or failure to replace it periodically. For this type of lead-acid battery, the electrolyte should typically be replaced every 2 years to extend the battery's lifespan. After separating the plates, the technician places them in a well-ventilated area to air dry, making them reusable later. The separators are also washed clean with water to remove any impurities and oxidation from their surfaces, then sun-dried. After a full day of drying, the plates are ready to be reassembled. The technician files the contact points to create a rougher surface, improving adhesion for the next steps. During the casting process, the technician uses a sturdy iron spoon to scoop molten aluminum, stretching it out to easily form new connectors. Any excess material is trimmed with scissors to ensure the connectors meet the required size and length. Next, fiber sheets are placed on both sides of each plate. This helps secure the plates and improves electrolyte absorption. The positive and negative plates are then separated and neatly stacked. The following step involves melting leftover materials from the manufacturing process. Once the temperature reaches 400 degrees Celsius, they become molten aluminum. The technician places a mold in the correct position, inserts the plates upside down into the mold slots, and pours the molten aluminum to join the plates securely at the contact points. He also uses a resistance welding tool to spot weld the joints, enhancing the strength of the entire structure. After welding, the assembled plates are inserted back into the battery casing. Due to the lack of high-tech equipment, the technician modifies how the plates are connected. Excess parts are trimmed, and a welding tool is used to connect the adjacent plates' terminals. So now the question is this type of connection a parallel or a series circuit? Once the connections are complete, the top cover is reattached by hammering it back into place. Then molten aluminum is used again to weld the positive and negative terminals. This step helps prevent electrolyte leakage during use. After welding, the contact points are filed smooth, and cylindrical molds are used to shape the battery terminals. Once the terminals are properly formed, the entire battery is sealed. A heated metal plate is used to press the cover tightly for a firm seal. Heated adhesive is applied to fill any remaining gaps, and a flat iron plate presses down to ensure a tight, leak-proof seal. After sealing the battery, the electrolyte solution is refilled. This solution is a mixture of sulfuric acid and distilled water at a specific ratio, with a density ranging from 1.24 to 1.35 g/cm superscript 3. Once the electrolyte is added, the battery only needs a full charge. At this point, the lead-acid battery has been completely repaired. So the question remains, where did all the lead-acid batteries you sold end up? Let's give credit to the incredible repair skills of the Pakistani technicians.